Hello, my name is Pablo Vaquero, and today I will be talking about my project in Forming Processes Consulting. So, in this project, I will be discussing three different types of consulting for different companies. The three of them are food industries, eco-mobility solutions, and finally, medical device innovations. Okay, so my first company to talk about is Soccer Pasta. My idea is to produce pasta in the form of soccer balls. Obviously, the material used would be the pasta dough, which is a highly malleable material and ductile, so it is easily shaped uh, into forms, so it is ideal for extrusion process. Then also I will be targeting the young audience. I think there is an empty space in the market of pasta, and this would be ideal for the purpose of this company, which is to increase the sauce and the meat that can be taken with this pasta. While I'm using direct extrusion, basically because I want a process that is continuous. I want to be producing pasta continuously, and I think that direct extrusion is better than, for instance, inverse extrusion, and so it's more efficient. Then regarding the cost of producing traditional pasta to extrusion pasta, I think it's not an important issue. I think the cost would be uh, really similar independently of the cross section selected for the pasta. We're not talking about metals. In this case, we're talking about pasta, so it's difficult to talk about mechanical properties, but as mentioned, instead of doing some hot working or cold working or some strain hardening, I will be talking about a process to try to increase the mechanical properties for our application. And finally, I will use olive oil as a lubricant, and I will explain it later. So this would be, for instance, the direct extrusion. Here we have the container in which the pasta will be introduced. This is the pasta dough, which is the billet. Then we have also the ram and the dummy block. Here the force is applied, so this is the moving part of the extrusion process. Here we have our die, which will contain the cross-sectional area that we want, the die holder, and finally the extruded pasta, which in the end would be cut. Here there's a more detailed. I'm gonna erase this. Sorry. Here's a more detailed photograph of the process. So we have our conveyor belt and the pasta dough, which will enter in the direct extruder machine. Here we have the extruded pasta, which is drawn in blue, but it cannot be seen. But this is the extruded pasta, and here are some cutters that will be going up and down in order to efficiently cut the pasta and introduce it in a container. Then we will introduce some salt or other ingredients to the pasta. During the process, I will be using olive oil, firstly because I think for the extrusion it's necessary to be lubricated because there may be some problems with pasta, which is a bit pasty. Um, and also olive oil, as we are targeting children, and olive oil is the best, like more healthy option instead of other types of oils. Then after applying salt, we would introduce it in other type of oil, also in olive oil, for some seconds. This is like really hot, okay? In order to fry the pasta for some time. And this would be like the mechanical process to enhance the mechanical process to enhance the mechanical properties. We would like it a bit crispy, that is increasing bit brittleness, reducing ductility. Um, This is also important so that the pasta keeps its shape after being extruded and cut. And when boiled, the pasta will still maintain its desired texture. Finally, we would let it cold and produce the packaging. And here you can see the cross section. It's not a radioactive sign. Okay, it's supposed to be the form of a soccer ball, and these spaces in gray is where the meat balls and the pasta and the tomato would be attached, and so the design is efficient for the children who want who really like the tomato and meat. Okay, so the second project is about eco-mobility solutions. In this type of project, we are required to create a bicycle frame that has certain properties such as strength, lightweight, and affordability. The material I chose, as we were required to use steel, I chose the stainless steel 304. Uh, if steel was not required, I would have gone for maybe some aluminum alloy, but steel is also a good option. I chose this steel because it has a good weldability, which will be necessary in order to weld the tubes of the frame together. It also has a good formability, which will enhance the facility to create the tubings. Uh, Corrosion resistance is also important, as the bicycle may have to withstand water and other substances. And also this although this steel is not really strong, it has a great balance between strength, weight, and cost, which were the requisites. Also, this material is already being used to form tubes, so I think that also explains my choice. And then the forming process chosen is to use hollow tubes because they are, as you reduce the material, you reduce the cross section, you are obviously reducing the weight and the costs. This process is named tube drawing. Okay, so the tube drawing basically consists on having a subjecting a tube to a series of hot dies in order to reduce its cross-sectional area. During this first stage, the material will be subjected to hot working techniques, and afterwards it would be subjected to some cold working. The applied force would be obviously in this direction to the right, and here is the interior of the process. It's important to include a mandrel which will determine the desired diameter for our part. This is crucial, as if we do not use the mandrel, there may be some internal defects that affect the microstructure and so the properties of our tube. Okay, so the characteristics of this process, firstly, it doesn't require lubrication. Thanks to hot working, the hot working allows the material to deform more easily, and that's why lubrication is not needed in this case. Then the first stage of hot working hot working has some important benefits. The first one is that you are required less forces than in cold working, which is important economic factor, and also that you increase the ductility and the formability. That is why, as I said, no lubrication is needed, and the forms can be easily achieved. And it also has good mechanical properties. However, as we would like to increase those mechanical properties, we introduce later a stage of cold working. In this case, the force doesn't need to be increased as the cross-section area has already been reduced, but it apports a great surface finish, which is important for a bicycle frame because, for instance, you may like to paint the frame and you need it to be polished. Then dimensional accuracy is also important for the aerodynamics of the vehicle. And as said, you would like to increase the mechanical properties, especially its strength. Moreover, cold working, you could also still continue doing hot working, but cold working is cheaper. And also another favorable characteristic is that you obtain a strength hardening, which is again really useful to increase strength and wear, which wear is a fundamental characteristic in a bicycle, as it will be loaded a lot of times and may reduce its tensile and compressive strengths. And finally, in order to cut those pieces, I think a good option would be to use hydraulic cutting, because the cross section is thin enough to be cut by water. And finally, to stick those parts together, I would probably choose either soldering or welding. Okay, so the last project is about medical device innovators. In this case, we are asked to design an internal fixation plate. This is basically support for our bones. For example, when we break our bones, they may introduce some of these fixation plates in order to help to healing and to be in our body for a long time. So the needs for this material would be to sustain what a bone would sustain. That is, that it needs to be strong and non-corrosive, as it will be in contact with the inside of our body. Then we were asked to do it with sheet metal working. This makes sense as the fixation plate is really thin. So working with sheet metal working is the most appropriate method in this case. The fact that we use titanium affects that I would like to perform some hot working before manipulation. This is because even though the properties of titanium are great in terms of strength, I think it's appropriate to increase its ductility, as it's going to be a part of our human body, and being brittle, it's not really appropriate because imagine the piece of titanium breaks inside of you, know. So I would like to increase its ductility and also formability in order to facilitate the sheet metal working. And also an important property of of hot working is to increase the fatigue resistance by changing a bit the microstructure. We need to take into account that this titanium plate would be for many years inside with our bones, and so we it needs to rest for a long time. Finally, as I said, to improve corrosion, I would introduce a surface finish, which can be, for instance, some ionizing of with cobalt, in order, as I said, to reduce this corrosion. Okay, so here's a sketch of how the internal fixation plate looks like. This is our boat. These are drills which are performed in the bone. So here, I guess, there are some screws. This red part would be the screw in order to be fixed. Uh, this implies that for every person, for every bone, the fixation plate would have a different pattern. and this is crucial in our manufacturing process. I decided, and it was also requested, to use blanking. Here we basically have this I'm drawing in red is our titanium plate, and we include here a really strong punch in order to be able to break the titanium plate. This will be like, if this is the surface of our plate, we'll have, and we want to perform, for instance, 5 holes, we would have this pattern, a machine having this pattern and performing the 5 holes at the same time. This is also great because imagine we want to change the pattern and we want to make 6 holes. We can change the pattern of our machine and perform 6 holes for the different applications we may be requested. Okay, so finally, the main characteristics of this process. First, in terms of cost, we need to highlight that this is a continuous process, which means that it can be running continuously, and the fact that we can also change patterns makes it really flexible and so efficient. We may have different customers or clients with, of course, have different medical needs. And so it's really easy for us to change the pattern of a single machine in order to perform the, the fixation plate. This would be the best option because any other option, I think, requires using a specific machine for every client, for every different design pattern, or consuming much more time than just changing the punch that will subject the force. In terms of string hardening, I do not think that titanium requires string hardening. It's really a strong material that the strength of titanium is already higher than the strength of a bone. So string hardening, which is usually done for increasing strength and hardness, it's not required in this application. We could do it, but it would involve cold working and so reducing the ductility that we had increased previously with hot working. Finally, the use of lubricant is not needed, and I don't think it's either recommended. The punch force is sufficiently high to cut the thin sheet of titanium, and the use of lubricant could let the punch to slip and to produce not desirable holes. So this is the end of my presentation. I hope you liked it, and thank you for your attention.